Welcome. Today we are demonstrating a massive milestone in open-source hardware simulation, integrating an OpenPOWER microwatt soft processor directly into eSim. It starts with our core building blocks, the microwatt VHDL source code, and our compiled C firmware. Using the NG-HDL compatibility layer, we cross-compile the digital VHDL core into an analog X-Spice wrapper. This generates a physical component that we can drop straight into our eSim schematic. Inside eSim, we wire the processor up just like a physical microchip. We drive it using a physical 100 MHz analog clock pulse and a transient reset signal. On the output side, we attach a voltage probe to the UART transmission pin to monitor the processor's behavior. When we click Simulate, eSim establishes a background socket bridge between the analog physics engine and a digital server. As the processor comes out of reset, it fetches its firmware and begins transmitting. What you are looking at is the hardware proof of life. This waveform captures the exact moment the processor transmits a carriage return and line feed, which are the very first bytes of its boot sequence. To prove we have cycle-accurate control, we modified the firmware payload to transmit a H sequence instead. Look at the waveform. Pulses spells out 0x48 in hex, which is the letter H. Without changing a single wire on the schematic, we swap the firmware again, this time to a V sequence. The simulation dynamically reacts, transmitting the letter V as a signal. This proves absolute cycle-accurate determinism between the software and the analog hardware. The future aspiration of this platform is to develop a seamless developer experience with maximized automation. This opens the door to incredible real-world applications, spanning across domains like IoT validation, reconfigurable hardware blocks, and hardware security. This is the future of accessible, open-source hardware validation.